Welcome. In this video, I'll be talking about an example of matrix A using the Kronecker delta function. So please subscribe and let's watch and comment afterwards if you have any questions. So the Kronecker delta function is an essential concept in linear algebra and tensor analysis. It is a function of two variables, usually integers, and is defined as follows. So let's say you have your delta function with subscripts ij. So if the subscript of, for example, in a matrix, like you see here, 1, 1, if the subscript is I and j are equal, then the function is equal to 1. The value is equal to 1. But if I and j are not equal, then the function value is 0. This function is often used in constructing matrices. Let's look at an example of matrix A using the Kronecker delta function. So let's construct the identity matrix that we all know about, that we've seen it before. So suppose we want to construct a 3 by 3 identity matrix A. The identity matrix is a classic example that employs the Kronecker delta function. Each element Aij of the matrix A can be defined using the Kronecker delta. Aij is equal to delta ij. For a 3 by 3 matrix, this definition implies. So any subscript I and j that are equal, for example, the diagonals, all those elements have equal I and j values. So that means that they're all going to be 1 using the definition of the Kronecker delta on here, you can see here. But any other than that is going to be 0 because the subscripts don't match, so the value of the function is 0. So using the Kronecker delta, so evaluating each element, using the Kronecker delta definition, we can still fill in the matrix. So as you can see, 1, 1 produces 1 as the 1 value, and then 2, 2, 1, 3, 3, 1. Any other than that is going to be 0. For example, 2, 1 is equal to 0, 3, 1 is equal to 0, because if you plug in here 3, 1, that means that 3 is not equal to 1. That means that it follows the second step, which is 0. Thus the matrix A becomes as the identity matrix, a 3 by 3 identity matrix, where the diagonal elements are all 1 and other than everything else is 0. So this matrix is the identity matrix, which is the fundamental concept in linear algebra, representing the equivalent of the number 1 in matrix operations. So some of the applications of the Kronecker delta are as follows. It is not only used in constructing identity matrices, but also plays a role in simplifying expressions in various fields such as physics and engineering, especially when dealing with summations and tensor operations. In summary, the Kronecker delta function provides a simple yet powerful tool for constructing matrices and facilitating complex mathematical operations. So you might be tempted to see how can you construct a matrix using a delta function, but that's possible. All you have to do is follow the rule, the function rule. If both subscripts are equals 1, you plug in 1 into the delta element. If not, you plug in 0 when I is not equal to j. That's how you construct a matrix A, a matrix. So the identity matrix is a very good example of the delta of an application of the delta function, but you can use it for other types of matrices as well. Thank you for watching. So please subscribe and comment if you have any questions.